Did anyone finish example 4 before lunch? Calculator? No? What? I don't know. Let's do it. Are we looking for x values or y values? Y values, good. Yeah, right, Waldman? Yeah, and we got a function that is continuous where? A combination of a sine and a linear. Everywhere, so it's also differentiable everywhere. We have a closed interval. That's good. So we know the IVT applies, the EVT applies, and the MVT applies. But we're looking for relative extrema here, and we know then that they can only occur on open intervals at critical values. So we got to find them. F prime of x would equal 1/2 minus cosine of x. Is that ever undefined? Nope. So we just set it equal to 0. And if we bring the cosine across and flip it around, we get cosine is equal to 1/2. Now it's cosine of 1x. That's good, because we can just use the unit circle now and find all the angles on the unit circle between 0 and 2 pi where cosine is positive 1/2. And they are pi thirds and 5 pi thirds. Good. Quadrants 1 and 4, right? Quadrants 1 and 4. So that we need to test in between there. So now we'll make our little number line chart. We got x, we got f prime of x, and we have pi thirds and 5 pi thirds. Now it's not going to be really an issue here for us, but we do have a closed interval. So when you're picking a number to the left of pi thirds, don't go past 0. If you're picking the number to the right of 5 pi thirds, don't go past 2 pi, because we are on this closed interval. 5 pi thirds. So what's the number to the left of pi thirds? From the unit circle. Pi fourths will work, good. And then between pi thirds and 5 pi thirds, there's a lot. Something nice, though. I would choose a quadrantal angle, like pi or pi halves. Doesn't matter. What do you want, Sean? Pi halves. Yeah, that's probably the better one. And then 5 pi thirds, something to the right of it. Well, let's see. It would either be 7 pi fourths or 11 pi sixths. We already used the pi fourths angle over there. Let's go ahead and give the pi sixths a shot at it, huh? 11 pi sixths. Now we plug it into the fully intact factored version of the derivative, but 1/2 minus cosine x doesn't really factor. So we'll just kind of plug in. If I plug in a pi fourths for x, I get cosine of pi fourths, which is square root of 2 halves. So 1/2 minus square root of 2 halves is positive or negative. It comes down to comparing that. Square root of 2 is a little bit bigger than 1, right? So 1 minus a number bigger than 1 is going to end up being negative. When you plug in a pi halves, what's cosine of pi halves? 0. Nice. So I get 1/2, which is positive. Good choice, Sean. And 11 pi 6, if I plug in cosine, I get